Okay, dear students, in this class let us discuss about the graph isomorphism, right? So here we need to check whether these two graphs are isomorphic or not. See, to check whether any two graphs are isomorphic or not, the very first thing is we have to check whether both the graphs are having number of vertices or not, or number of edges or not. If they are having number of vertices, if they are having same number of vertices as well as same number of edges, we cannot come to the conclusion that whether they are isomorphic or not isomorphic, right? If both the graphs are not having the same number of vertices, if both the graphs are not having the same number of edges, we can come to the conclusion that both the graphs are not isomorphic. So look at this graph here. We have 5 vertices. There also we have 5 vertices, and here we have 4 edges. There also we have 4 edges. So we cannot come to the conclusion that whether they are isomorphic or not. So let us move on here. Let us calculate the degree sequence. Let us consider the degree sequence here, right? These are the vertices. What is the degree sequence here? So the degree sequence is the degree of A is 2, the degree of B is 1, pendant vertex, the degree of C is 3, the degree of D is 1, and the degree of E is 1. And what is the degree of this vertex here? So we have P, Q, R, S, T. What is the degree of this? The degree of P is 1, the degree of Q is 3, and the degree of R is 1, and the degree of S is 2, and the degree of D is 1. Right? So look at that degree sequence of these two graphs. This is the degree sequence of the graph G. This is the degree sequence of the graph G dash, and both are matching here. Right? We have only vertex of degree 3. So we can say that there is a 1-1 correspondence between the vertex C and the vertex Q. So let us write the 1-1 correspondence between 1-1 and 1-2 correspondence between the vertices. Right? Let me consider the vertices of G. Right? So let me show the 1-1 correspondence between the vertices of G. So here we have only one vertex of degree 3. Here also we have only one vertex of degree 3. We can say that these two vertices are in 1-1 correspondence. So I can say that the vertex C is having 1-1 correspondence with the vertex Q. And in this graph also we have only one vertex of degree 2. In this graph also we have only one vertex of degree 2. I can say that the vertex A is having 1-1 correspondence with the vertex S. Now we have 3 vertices of degree 1. There also we have 3 vertices of degree 1. See, in order to find the correspondence, the 1-1 correspondence between these two vertices, so let us consider the vertex C. It is having the degree 3, right? So what are the degrees here? What are the adjacent vertices of C? It is A, D, E. It is A, D, E. And let us consider the vertex Q. It is having 3 adjacent vertices, namely P, R, S. P, R, S. See, among okay, we have these. Okay, and here we mapped C to S, and we mapped A to S. So we mapped this, right? Okay, just like this. Now we have 2 vertices D and E, and we have 2 vertices P and R. We have to check the vertex D is having 1-1 correspondence with which vertex or not. So let us consider the vertex A, which is having of degree 2. So it is adjacent to what? It is adjacent to B and C. And we have on vertex S of degree 2. So it is having 1-1 correspondence with what? Q and D. Right? So here C is already mapped with Q. Right? The only one thing is we have B and T. So that is the only one vertices are there here. So we have vertex B here, we have vertex T here. We have to map B to T. So we can map this B to T. Right? So now we mapped B to T here, right? Fine. So now we have the vertices D as well as E, and we can consider okay, we map this also, right? So we have D as well as E. So we have the vertices P and R remaining, right? Fine. So here we have P here, right? So here we have D as well as E, and we can say that P maps to D, and we can say that Q, or what Q maps to R. Right? We can take any vertices here. Fine. So this is the one-one correspondence between the vertices. Now let us check the one-one correspondence between the edges, because the edge preserving property must be also there. Okay, then only we can say that these two graphs are isomorphic. Fine. So let me consider the edge AB. Right. So here we have a one-one correspondence of A. So A is maps to what? Yes. And B is maps to what? T. So look at this figure. Do we have an edge between S and T? Yes, we have. So we can say that this vertex is preserved in this section. These two vertices having, these two edges having one-one correspondence, one-one not-two correspondence. Right. And let us consider this edge. What is that? It is EAC. Right. So here A means what? A is maps to what? Yes. And C is maps to what? Q. So do we have an edge between S and Q? Yes, we have that. So this edge is having one-one correspondence with this. And let us consider C and D. So C is having one-one correspondence with Q, and D is having one-one correspondence between P. So do we have an edge between Q and P? Yes, we have. So this is having one-one correspondence with that. And we have C and E. So what is C here? C maps to Q, and E maps to what? R. So do we have an edge between Q and R? Yes, we have. So we can say that there is a one-one correspondence between the vertices as well as the edges. So we can say that these two graphs are isomorphic.